Okay, I'm going to talk a little bit about the specific interface of Grasshopper, just on a very technical level so that we can understand what's going on and what buttons you have to click in before we jump into more interesting and exciting things about what you can do with Grasshopper. So first you open Grasshopper by typing Grasshopper in Rhino, which will load Grasshopper. And what you're seeing is there's this kind of screen in the background, which is this kind of component field. It's an area where you can drag things and start to lay out your Grasshopper component or solution. And as you can see, what I'm doing is there's a toolbar up above that has many different types of components that I can drag down. The toolbar has a bunch of tabs with different types of things, and as you can see, this tab is about math, this tab is about curves or surfaces, this is analyzing surfaces, freeform surfaces, primitive surfaces, and I'm sure you can get the hang of things pretty quickly. And you can drag things down into the screen, or what you can do is you can double click and say type circle, and it'll search and find all the different types of things that are related to circles, and you can click on something and create this. And then you can select all these things together and then delete them. You can move them around together. You can right click, and there are all these different options. And we'll go into those things later, but the general thing you have to understand is that there are these components or objects that you're working with. So the basic logic in Grasshopper is this idea of chaining, and I'm going to create a circle. It's here. I've double clicked and typed circle. Or I can also go up here to the menu bar, click on curve, and look for primitive. And down here it says create a circle defined by base, plane, and radius. And I can click and press it to place it on the my board. So what this basically does is it's a component. It takes these are inputs on the left and these are outputs on the right, and it says circle here. If you see a different view, you can go up to the view menu, actually sorry, the display menu, and you can click on draw icons, and it'll change this to an icon. But I personally find that it's more convenient or faster to have it show the text rather than the icon. So the left-hand side of this component are a bunch of inputs. They will always be on the left-hand side. And on the right-hand side, the inputs, they're outputs. And so if you hover your mouse over the input, it'll tell you what it needs. It needs the base plane of the circle, which is the XY plane. It says it's already in there because you can see it says one locally defined value. And R is the radius of the circle, and it says one locally defined value 1. On the right-hand side, you get the resulting circle. So you have a circle radius of 1 meter. And sure enough, if you look on the Rhino screen, there's a circle that's been created here. So if I change this input, I'm going to go into the parameters menu, go into the input menu where there are all these inputs created, and I'm going to use a number slider. I'm going to click. I can also, there's a shortcut, I can double click, search for slider, and click on the number slider. Or I can also just double click and type a number. Let's say I type 6.5. And then I can click on it and it'll give me a number slider that's automatically set to 6.5. This is very helpful sometimes. So I'm going to create this number slider which gives me a bunch of numbers that I can use a slider to change. And then I'm going to create a panel item from the input menu. That's basically a giant field that can represent information, data, anything. It's used very often to debug or re-examine what you're working with. And if you ever have a problem with your code or your Grasshopper component, the panel will come into handy. Another shortcut for this is to double click and type the quotation mark. That'll automatically give you a panel as well. So I can link these components together by dragging my mouse, holding my mouse over the output, clicking on it, dragging it to the input, and you'll notice it starts snapping to things. I can't connect outputs to outputs, I can't connect inputs to inputs, but I can connect an output to an input. So now it's showing me the result of the slider, and I can move this thing the slider and watch the value change. So then if I connect this to the radius, you can see that as I move the slider, the radius changes. And thus the circle changes as well. And so what I'm getting out of this, actually, if I create a panel and I plug the circle into the panel, as I can see there's a circle. But of course the output of the circle can be an input for another thing. So let's say I have the extrude command, which I'm going to type in and find extrude. And the extrude command takes in a curve or a surface as an input and a direction, extrusion direction as an input, and gives you an extruded form. So if I plug the circle into extrude, you would think it would work, but it actually gives me an error, and you can see this little balloon on the right hand upper side that if you hover over it says input parameter D failed to collect data. So sometimes when your component isn't working, you have to debug it by seeing why, and it's because it's still missing information, and oftentimes components will want all of its inputs filled in to be able to function, even though some inputs don't have to. For example, the circle one, it has a default set in. Extrusion, it really wants you to specify the direction. So if I give it a direction, it's actually a vector, and in vector I can grab the z vector. This is one of the default vectors that it's conveniently given to me, and I can plug the z vector into the direction, and it's extruded. And this z vector also has a factor, so I can amplify or change the amplitude of the vector. So let's create another slider, plug it into the vector, and now I can change how much it's extruded. And then I can also change the original radius of the circle, so then you see that I'm creating a final form or a cylinder that I can adjust programmatically. And you can imagine things chaining onto it onwards onto an eternity, like things chain onto this and onto this, so that a slider you adjust at the start has hundreds of repercussions down the line and changes a lot of different things. And in some sense that's what people say when they talk about parametric architecture, that it's parameterized or highly there's a very quick feedback loop between the parameters you're using and the final design you see. So if you had if this was your building, let's say, let's actually cap this. So now it looks more like a physical form. Let's say this was your entire building. Then this building is parameterized based on your radius of the site, of the base envelope of the building. And you can continue to chain things together. Just because we're going over the interface in this video, there are certain tools over here that are actually sometimes helpful. This will change the quality of the preview mesh. So if I want it to be high quality, you can see that this view looks a little nicer, more accurate. I can also enable this button, which only draws the preview geometry for the selected object. What that means if I turn it on is everything disappears unless I click on the circle component, and it only shows me just what the circle is doing. Let me change the color so you can see it more visibly. If I click on the extrusion command, it only shows me what the extrusion command is doing, and if I click on the cap command, it only shows me what the cap command is doing. That can be really helpful when a lot of stuff is going on and you need to kind of walk through to check if everything is working, or at what point your thing might not be working. And then there are other tools that we can go into briefly. One thing that might help on the long run is make sure that obscure components is on. It's kind of nice to see the full range of what's available to you. There's also under display, there's this thing called canvas widgets, and make sure the message balloon is definitely on, and it can help to turn on the profiler. What that does is it tells you how long something took. So this took 6 milliseconds to run, which is 93% of the time it took this entire thing to run. And when you're working with large files and things get slow, it really helps to figure out, like, oh, this is really heavy. I'm making my geometry really heavy. So that's kind of the basic logic of Grasshopper. Things chain into each other, and I've capped this, I've extruded this, I have this circle. I can also move this form. So this has been moved, but let's say I want to move this in the x direction. So I give it an x vector, it's moved a little bit. Let's say I want to move it by 30 units. Maybe it's 30 meters in this. And then so depending on how I move this slider, the amount it's moved has changed. So on and so forth. And a few other things. There's the right mouse button, which gives you more interfaces or more options. So you can also turn certain things off from view. So if you have a circle, you can highlight it, click right click, undo the preview so that you don't see the circle anymore. Let's say you only want to see the final result. So I'm going to right click and click on the preview. And I'm also going to right click and undo the preview on the cap, so I only see the object that's been, say, moved. It's still vary all of the initial sliders. These things have just been hidden from view. The last thing is, so you have, let's say, this geometry. This is a little kind of container just to hold any kind of geometry in it. How do you bring it back into Rhino? So you can right click and click on bake, and you can say I want it to go to the default layer. Press OK, and then now if we close Grasshopper, it's an actual object in Rhino. It's not just created temporarily, and so I've baked it, which is a one-way process to kind of make it more concrete in some sense. And so if I change the sliders, the object that I've baked isn't going to change. Now, what in this example, I haven't used any geometry in Rhino. Actually, I've only created a circle and done this extrusion. But let's say actually the circle I want is around a point, and I want to define what point that is. I'm going to create geometry in Rhino, and notice this is Rhino geometry, not in Grasshopper. And I can double click and create a point component which holds points. What I can do is I can right click on it, and I can ask it to set one point or multiple points. I'll click on set one point, and then in Rhino it'll ask me point object reference, so I'll click on this point, and then that means that this component or this node is referencing this point. So if I move this point around, what's in here also understands that it's been moved. So that means I can plug this point into the circle object. And actually let me preview it so you can see what's going on. So then the circle is being made around this point. If I move the point, so does the circle. If I enlarge the radius, the circle is enlarged around the point. So then there's this feedback loop between what you're doing in Rhino, the processing that happens in Grasshopper, and the final output back into Rhino. And that's the kind of basic structure of any given Grasshopper component. Okay, I'm going to go into some aspects of the Grasshopper interface that's just advanced, and even if you've been using Grasshopper for a while, it might be helpful to know these tools. Certain aspects, you can highlight a few tools and middle click, and you can group them together. You can also press Ctrl G to do that, which means that you can move things in a group. Sometimes what I like to do is I like to group my inputs, and you can group the group, and then group the group, so that visually speaking, you kind of have this purple thing that lets you know at a glance what you can do. The middle mouse also scrolls in and out. I guess that should have been obvious. But you can double click on the group to kind of create this representation of the input. Some other aspects. From a conceptual point, Grasshopper stores geometry in these nodes, and there's a lot of different kinds of geometry. There's points, circles, lines, planes, rectangles. These geometries only hold those things. So, for example, let's say I have a curve component, And in Rhino world, I have a lot of different curves. I have a circle. I have a plane. Let's say I have a polyline. Let's say I have this polygon extruded, etc. If I try to plug all of these things into curve, I set multiple curves, and then I see what comes out. It will only give me the curves and not, for example, the extruded objects. Let's say I plug this geometry into a geometry node. And I plug this into curve. Curve will give me a little error because if you hover over it, it says data conversion failed from point to curve. So I'm giving it all this stuff, but it's when it encounters a point, it gives you a little warning and says I couldn't deal with that point. So instead it just gives you everything that comes through it, which is actually a curve, excluding that null item. And you can use these objects as a way to kind of filter for certain kinds of geometry. There's a lot of other interesting things in the input and the outputs. There are toggles that let you turn on and off. There are buttons. There's utilities that do things like they record data, or you can do genetic algorithms, or you can use a graph, and like graph all these different values. I won't go into the details of all these things, but it's important to know that on a conceptual level, what you're doing is you're taking data, you're processing it through a variety of means, and then you're outputting it as more data. In this section, in the math section, there's a lot of scripting possibilities. You can incorporate Python or C# or VB.NET. There's a lot of mathematical operations that can be done. You can even create your own custom expressions, mathematical expressions. If you double click, so you can do like x plus y, squared, etc. And that's a way to do mathematical kind of notation or mathematical operations within Grasshopper. There's sets where you're dealing with lists of items, so you can have a lot of different items. I'm going to go back to our kind of circle example. And you can deal with a series of items. For example, let's take the actual number component series. This generates a series of numbers. I'm going to use the panel to see what's going on. This should be kind of a default move a lot of the times. So if you hover over the component, it says this creates a series of numbers. The first number series is 0. The step size, or how much it increments, is 1. And it gets you 10 numbers. So if I set the step size to be 2, instead of going from 0 to 9, I'll go from 0 to 18, or 0 to 4, 6, 8, 10. If I only want 5 numbers, then I'll do give me 5 numbers or 5 series. Now I can use this. This is a list, and I can pipe this into, instead of this x value, I can plug this into here. And as a result, this capped cylinder is moved in the x direction by 0 increments, 2 increments, 4 units, 6 units, 8 units. If I expand this, you can see that the distance of these things increases in proportion to the slider. And then if I change the number of series of numbers that this component is outputting, it arrays it outwards. Again, I can go back to the initial circle, change the radius of all of the circles, and change how much they're extruded. It's convenient to help every component I can right click on, and I can change the name of it. So I could call it R. I could call this thing extruded height. I can even change the name of this thing by right clicking on it and saying make a circle. the name doesn't change the function of it, but it's a very, very, very convenient way to tell yourself what this component is actually doing, because sometimes it's easy to lose track of, you know, the objects within a Grasshopper script or Grasshopper file if you have a lot going on. So instead of calling this series, I might say values to move and so all of this stuff are list operations. So let you grab items from a list. So let's say I have now if I see the output, I have all these different objects, and I can plug these into the list. And let's say I want the fourth object. So this will give me the fourth object. Actually, technically, this will give me the fifth object because, and oftentimes in a lot of programming, objects start from 0. Lists start from 0. So the first item in a list is the 0th item, first item, second item. So you can see that as I move the slider, the object that this component is pulling out of this list changes. Trees I'll cover in a future tutorial because they're kind of a little bit more complex ways. They deal with how to deal with large streams of information and how to process different streams of information together. You can work with text, you can work with sets, you know, so if you do kind of logic or more Boolean, you can create sets of unique objects, you can intersect them together, union them together. You can do things like repeat data, you can shuffle values, you can randomize values, you create random values. You can control, create and control color. You know, you can create like fields of charges or display these vectors on a field. Work with planes, vectors, points. Basically everything you can do in Rhino, or more like everything you can do in a 3D software, can be described and represented to some extent with these tools. And of course there are a lot of other tools or other components that may be helpful, but it's a pretty comprehensive list of operations. You can split a curve into multiple points with divide. You know, you can get the tangency at that curve with divide. You can make new points, make interpolated curves, you can make polylines. You can make surfaces, loft surfaces, figure out the area of a surface, the volume of a 3D object. You can work with meshes, intercept objects together, and figure out where they intersect, how they intersect. You can transform and modify things, morph things, scale things, twist things, rotate objects, array them. And then there are a lot of also feature components that you can work with. These are ones that I've installed. Weaverbird, which works with meshes, Millipede, which is a kind of a physics model, Kangaroo, which is like another physics modeling software or plugin, Lunchbox, which does a lot of paneling, and all these components you can download for Grasshopper. And there's actually a really, really comprehensive and very active ecosystem of components. This is GHOW. You know, you probably won't have this tab unless you specifically install GHOW. And this lets you grab information from Google Earth or export information to Google Earth. This gives coordinates and, you know, long coordinates and converts them to XY. This gets data over a network and gives it to you as information. This controls the camera, or it sets the camera. So, and you can download all these things, and the plugin, the kind of plugin aspect is one of the main reasons I would say that makes Grasshopper very strong. There are plugins that interface with Revit, with Ecotech, that grab data from Flickr or Yelp. There's plugins that, you know, let you work with GIS data. There's plugins that let you work with Arduino, or even plugin with processing, or you know, use external input devices like, you know, a Kinect or the iPhone's accelerometer. You can post information to the internet, and the sky is kind of the limit, especially since you have programming languages such as Python, which is a very, very powerful language that is also very good to learn as a beginner language. And with this, in conjunction with all these other components, you can pretty much do anything and everything. Let's see, we can go more into the details of Grasshopper as we work with specific objectives in the rest of the other videos. But I hope this gives you a good idea of the general interface of Grasshopper.